Hello, calculus fans! Alright, so let's try our new technique of integration on this one. We're going to evaluate the integral of x cubed times the square root of 4 minus x squared dx. Now, the substitution to make is to let theta equal arc sine of x over 2. Well, how do we know that? Well, we have this expression here inside the integral, a square root of a squared minus x squared, and according to the chart that we gave in the last video, this tells us to make the substitution arc sine of x over 2. Now, once you have theta equals arc sine of x over 2, that means sine theta is x over 2. Now, what I'd like to do is draw a triangle that's going to relate theta and x. I'm going to draw a right triangle that indicates that sine theta is x over 2. All right, let's see what that looks like. All right, I've got a triangle, a right triangle. We're going to base this on sine theta. If sine theta is x over 2, then that means the opposite side is x and the hypotenuse is 2. Now you should probably take a moment now. Can you figure out what the length of this side is? You have a way of relating the sides of a triangle, a right triangle. You can use the Pythagorean theorem. So take a moment now, see if you can figure out what the length of that side is. Stop the video and work it out. You should get square root of 4 minus x squared. So this is a pretty easy thing to do, actually. If you have two sides of a right triangle, you can always work out the third side using the Pythagorean theorem, no matter which side is missing. Okay, now keep the picture of that triangle running around because we're going to use that. I'd like to piece together our substitution, and we may have to refer back to that triangle. So now remember that theta is equal to arc sine of x over 2. So sine theta was x over 2. So we got all that already. And now 2 cosine theta is equal to the square root of 4 minus x squared. And that's actually also going to be based directly on the triangle that we had. We also know that 2 sine theta is equal to x. And so if we differentiate that, we'll get 2 cosine theta d theta is equal to dx. Now we've got everything we need to actually be able to evaluate this integral. We figured out what x is, we figured out what dx is, we figured out what square root of 4 minus x squared is. We have each piece of the substitution ready to transform from x's into thetas. So we've got our original integral, which was the integral of x cubed square root of 4 minus x squared dx. And then if we transform that, the x cubed at the beginning turns into 2 sine theta quantity cubed because x was 2 sine theta. The square root of 4 minus x squared turned into 2 cosine theta. And then the dx turns into 2 cosine theta d theta. And then in the next line, I just put all these together to give us, if you work it all out, you'll get 32 times the integral of sine cubed theta cosine squared theta d theta. So you should probably make sure to stop, that you have all the pieces put together, that you see the transformation from the x to the theta integral, and then the cleanup into what we have now. Okay, so now we'll go back to our techniques for evaluating these sorts of trigonometric integrals. I'm going to remove one of the sine thetas and put it in the back of the integral, and now we'll convert this sine squared theta into cosines using just the ordinary Pythagorean identity, because now we're going to make yet another substitution. Because I see a du out here, I'd like to substitute for cosine. All right, so if we let u equals cosine, then du equals negative sine theta d theta. Of course, we move the minus sign back over to the du. Okay, now let's put all this into the integral. So we end up getting 32 times the integral of u squared minus u to the fourth times negative du. I'll just run the negative back into the integrand, so it really turns into 32 integral of u to the fourth minus u squared du. Aha! Now this is an easy integral. We get 32 times 1/5 u to the fifth minus 1/3 u cubed plus c. Make sure you put the plus c the moment you compute an antiderivative. Up to this point, it's just been making substitutions. All right, now we got to wind back to the original variable, which was x, and this is going to be a two-stage proposition. First, we'll put the u back in. So remember that u was cosine theta. Next, we're going to put the theta back in. And the way we do that is, remember that we have our triangle. You should be referring to your triangle. According to the triangle, cosine theta is square root of 4 minus x squared over 2. So we can put all that in there, and actually, this is our final answer. Remember, that last replacement was because we said that 2 cosine theta was square root of 4 minus x squared. You should be able to see that from the triangle. And I think it's actually worth trying to figure out if there's another way to evaluate this particular integral. Lots of integrals can be evaluated in multiple ways. So, in my class, how about some extra credit? Bring in an evaluation of this integral in another way, maybe not using a trig substitution. Okay, that's all for now.